The following problem. Consider infinite ladder of identical resistors. Find the equivalent resistance between A and B. This is a no, it's not a very hard problem, but it does basically test what we know to the max. All right, so let's just go ahead and just try to do it. All right, so let's look at this problem very carefully. All right, and the way we're going to do this is basically we'll redraw the circuit as follows. All right, let's basically look at this part right here, and then let's imagine I take all the rest here onward and I lump it into something called a equivalent resistance, REQ. Okay, so what I'm going to have is that basically uh, so this circuit right here is really REQ. All right, and what is REQ? Well, REQ is basically the sum of these things on itself. So we're going to imagine this is one equivalent resistance, right? And then basically build up on that. So REQ basically consists of the equivalent resistance. REQ is equal to what? Well, this is connected in series, and then this part right here is also REQ again, right? So the way to think about this is that this resistance, REQ, that's going to be the sum of the top circuit R, this circuit R again, and then another REQ. Okay, so REQ is basically this circuit, right? And then this circuit is just another version of REQ going onward. All right. So if we were to write this down, this equivalent circuit right here, which we call REQ prime, 1 over REQ prime, because it's connected in parallel, is 1 over R plus 1 over REQ. Okay, and this part right here is connected in series. REQ, which is the entire thing, is equal to REQ prime plus R. So this is 1 over R plus 1 over REQ plus R. Okay, this is equal to REQ. Okay, so if you get to this point already, you're essentially done. All right, so we're going to go ahead and we're going to basically finish this one off now. All right, so it's just basically solving this problem here. Right, so how can we solve this problem? Well, perhaps the easiest way is to somehow try to get rid of this stuff down here, basically, right? Or you can multiply this one out, right? Perhaps it's easier just if we just multiply this one out, right? So let's basically make this one. Let's multiply the entire thing by 1 over R plus 1 over REQ. Okay, we'll multiply everything out, right? So what you're going to get in this case is you're going to get basically this is equal to this times this is 1 plus R times that, so it'd be R times 1 over R plus 1 over REQ is equal to REQ times 1 over R plus 1 over REQ, right? So this is going to be 1 plus 1 plus R over REQ is equal to REQ over R plus 1 again, right? So one of these ones are going to cancel each other out, and the rest we have to just somehow flip this thing, right? So I want to get REQ, so I'm going to multiply this again by REQ, right? And so if I do that, I'm going to get REQ plus R, right? That's REQ times R, is equal to REQ squared over R, right? Or written in the quadratic form, this is REQ squared over R minus REQ minus R equals 0. Okay, so how do we solve this problem? We use the classic quadratic formula. So imagine you have a form of the form ax squared plus bx plus c equals 0. If you have this form, the solution is x is equal to minus b plus or minus the square root of b squared minus 4ac divided by 2a. All right. Now, you might be disturbed by the fact you get plus and minus here, so you get actually two solutions to this equation, and you should get two solutions to the equation, but only one of them is going to be physically relevant, right? And in particular, when we go through it, you can see that one of them is going to have negative resistance, which is impossible, physically impossible. So we must choose the one with positive resistance. All right, so in this case, basically A is equal to 1 over R, B is equal to minus 1, because it's minus 1 times REQ, and C is just simply equal to minus R. Okay, so let's plug in this equation right here. So REQ is equal to minus B, which is 1, plus or minus the square root of B squared, which is now 1 again, minus 1 squared, minus 4AC, so it's minus 4 times A is 1 over R, times C is minus R, divided by 2a, 1 over r. Okay, so this is minus 1r times 1 over r is a minus 1. Minus 1 times minus 1 is a plus 1, so it's 1 plus 4 is 5. So it'll be 1 plus or minus square root of 5 divided by 1 over r. All right. Now, like I said before, there are two solutions here, but one of them you will see basically is 1 minus square root of 5. Square root of 5 is bigger than 1, so this will be negative. So the only relevant solution is going to be this one. It'll be 1 plus square root of 5 over 1 over r, or REQ is equal to r times 1 plus square root of 5 over 2. All right. Hope that was helpful.